fellow mathematicians, welcome back to another video. At the end of each and every playlist, we are basically at the end of the exponentiation playlist right now. I'm going to show you either something really curious like 0 to the 0th power, or why negative times negative is positive, or I'm going to present to you a little practice session. There's always going to be a practice session. And this is what we are going to do today. And you can try out those exercises now, pause the video, and after you're done, you can basically watch the video if your solutions were right. So here are the first two exercises, and here are the last two exercises. I hope you know what I mean by those exercise titles, basically, what you have to do. And yeah, I'm going to give you 3 seconds now, 3, 2, 1, go, and we are going to dive right in. Here are the solutions. We're going to start off with the first exercise. Simplify those expressions as much as possible, or collect terms. It really depends. And we are going to make use of our exponentiation rules that we have derived before. We're going to start off with a to the 0th power times a to the 3rd power. And obviously there are going to be many different ways to solve something like this. So in all of those exercises, we are going to go with 1 or 2 ways per exercise. And yeah, let's go ahead and get started. So if a is not equal to 0, then a to the 0th power is always going to be 1 in some way. And then we are going to have 1 times a to the 3rd power. If you only have 1 times a to the 3rd power apples, then you only have a to the 3rd power apples. Meaning 1 times a to the 3rd power is just a to the 3rd power, obviously. But there's a different way. I want you guys to notice that we have the same base right here. Meaning we can make use of the exponentiation rule where we have the same base but different exponents. Meaning we are going to collect the base that they have in common, and then we are going to add our different exponents together. 0 plus 3 is going to give us 3, so a to the 3rd power. If you don't know what those exponentiation rules are, or what we are actually doing here, take a look at the top of the description. There will be a link to the corresponding playlist, and then you can watch everything and come back to those exercise sessions here. Now, next up, b to the 5th power times b to the negative 2 power to negative squared. What do we have here? Well, we have the same situation as up here. We have same base, but different exponents. Meaning we are going to collect the same base, which is b, and then we are going to add our exponents together. 5 minus 2. 5 minus 2, if you have 5 apples and I take 2 away from you, you only have 3 apples. So b to the 3rd power, b cubed. And thus we are done with this exercise. Now what about a to the 3rd power times b to the 3rd power? Other situation. Different bases, but same exponents. What was the rule for that? Well, we are going to collect our bases, multiply them together in parentheses, so a times b, and we are going to basically use a distributive law. I'm terribly sorry. We are going to drag our 3rd power to the outside, basically. Okay, a times b to the 3rd power. I'm being speech disabled right now. I'm terribly sorry. Have recorded a lot of videos today already, so my mouth is a tiny bit dry. So a to the 1st power, that's an easy one. Some number to the 1st power is just a number in itself, okay, just a base in itself. So this is a, and we are done. That was really easy. Now a squared times b to the 4th power, that sucks, right? I mean, we have different bases, but also different exponents, meaning we can't make use of a really nice rule right now. We need to use some other things to simplify this a bit further, or to express it a tiny bit different. I have made 2 videos on the topic with different bases and different exponents. We are going to make use of the fact that we can express 4 as 2 times 2. So 4 is nothing but 2 times 2. Okay. This is good. We have the multiplication of exponent parts, basically. This is the same as exponentiation of exponentials, meaning b to the 2 times 2th power is b squared, and the whole thing squared yet again. So we are going to put parentheses around the squared, and we are going to square this thing yet again. We had an exponentiation rule for this. And this is good. Now you can call b squared, for example, x, and then you're going to end up with a squared times x squared. Different bases, same exponents, meaning we're going to turn this into the multiplication of our bases, so a and b squared, a times b squared, and we are going to drag our common exponent to the outside. And thus we have simplified as much as possible. We have collected the terms successfully. And next up, a squared times b to the negative 2th power times a to the negative squared times b to the 5th power. There are a lot of ways you could approach something like this. I mean, here we have, right in the middle, different bases but same exponents, for example. Okay, we could use a rule we have applied before, 3 times thrice. But there's actually a better way. You see, we have basically same bases here too, 2 times the same bases. Meaning, what we could do is we could use the commutative laws. So if you have 3 times 2 apples, that's the same as 2 times 3 apples. We can interchange the multiplication here, turning this into a squared times a to the negative squared times b to the negative squared times b to the 5th power. And this makes matters way easier because now we have same base, different exponents, leaving us on the one hand with a to the, so that's the same base, 2 minus 2th power times b to the negative 2 plus 5th power. Okay, good. 2 minus 2 is going to give us 0, and as long as a is not equal to 0, we have something to the 0th power is just 1. Okay, this is a to the 0th power, it's nothing but 1. And b to the negative 2 plus 5 is going to give us b to the 3rd power yet again. This is what we had here too, b to the 3rd power. So this thing right here is nothing but b to the 3rd power. And if we have 1 times b to the 3rd power, it's just b to the 3rd power. And thus, we have simplified as best as we could. And this concludes the first exercise, and I hope you had everything right if you did this in the shadows, this exercise, and now came back here for the solutions. Next up, we want to turn those 4 expressions into fractions. Now there was an easy Eselsbrücke, like an easy mnemonic device I gave you back in the days. Namely, if we have negative exponents, what we did was turn our negative sign into the fraction bar, the vinculum, and then put a 1 on top and the rest underneath the vinculum, so into the denominator. What this means is, negative sign turns into a fraction bar. A to the 3rd power is left, put it underneath and put a 1 on top. And then we're done. Alright, same spiel here basically. So negative sign into vinculum. 4 squared is going to be left, and up here we're going to have a 1. Easy as pie. Easy as pie? Ooh! Do I sense a pie here? That's my stunt to this. Pie. Golden pie. Okay, now 2 to the negative 12th power. Turn negative sign into the fraction bar. 2 to the 12th power is left. 1 on top. And thus we're done. Now for the last one. Now we have the multiplication of things. A to the negative 3rd power times b to the negative squared. Thing is, we can multiply fractions together, which is good. So at first we are going to acknowledge that we have multiplication of things. And now we are going to turn a to the negative cubed and b to the negative squared into fractions respectively and then multiply them together at the end. So a to the negative 3rd power is nothing but, okay, negative sign into fraction bar. A to the 3rd power is going to be left. Put a 1 on top, and thus we are done. And multiply it by b to the negative squared. Negative turns into vinculum. B squared is going to be left, and a 1 on top. And now we have the multiplication of fractions, meaning we are simply going to multiply top and bottom together respectively, pointwise, leaving us with 1 times 1 being equal to 1 over a cubed times b squared is just what it is. It just is what it is. We can't simplify any further right here. And that's it. We have turned those into fractions. Did you get it right? I do hope so. You're a smart boy, I know it. Now next up, which signs do the following terms have? Sign means, do we have a positive sign or a negative sign after basically evaluating these terms? Now let us think back. If we have a negative base to some kind of negative or positive integer exponent, then we can have 2 cases. If the negative base is raised to an even power, for example 2, 6, 8, then it's going to be a positive sign at the end. So just our base, basically, without the negative sign. If we have an odd exponent, for example 1, negative 5, negative 7, 19 on the other hand, then we are going to have negative 1, basically, times this thing raised to the power. Now let us see what our power actually is. I mean, we have a negative base, this is good, so we need to take care of the casework. Now we have, what power? Is this odd or even? I mean, 4 is 2 times 2, meaning it's divisible by 2, meaning it's an even number. Thus, we are going to end up with positive 3 to the 4th power. This is just something that we have found out before, meaning overall that, well, it has a positive sign, a plus in front of it basically. And that's it. That was the exercise, first part. Now 5 cubed. That's gotta be a joke, right? I mean, 5 is a positive number, raised to some power, it's not even a negative base. So are you kidding here, Papa? Yes, I am. It's just a little fun exercise, okay? It's just a Fangfrage, basically. So this is 125, it's obviously positive. So we are done with that. Now what about a negative par to the negative 3rd power? Once students see the number par here popping up, it's already Zahltag, payday. They have no idea what's going on. This isn't a number for them. It's a weird symbol, doesn't make any sense. But we don't care, it's a negative base, whatever the frick this is. What about the exponent? That's the only thing that counts. Well, our exponent is exactly an odd number. Negative 3 is odd, just like 5. It's also odd. Meaning overall, we are going to end up with a negative sign in front of our base to the negative 3rd power. Negative pi to the negative 3rd power. If you don't like this notation, because for many students it's ambiguous and they don't know what's going on, put parentheses around it and then you are basically good. Our solution here is negative pi to the negative 3rd power. What about negative 12 to the 100th power? Now, basically sets of numbers playlist pops in yet again, pops up right now. So we are going to have negative 1 times negative 12 to the 100th power. Please note that our 100th power only applies to our negative 12 here. Let us go through the casework. I mean, we are going to drag our original negative to the other side of the equivalence relation here, equals 2. And then negative 12 to the 100th power. We have a negative base raised to a what power? It's an even power, right? Meaning we are going to end up with 12 to the 100th power. Now we have this kind of ambiguous notation yet again. We're going to put parentheses around it. Gets rid of the problem. Negative 12 to the 100th power. And then we're done. Did you get it right? I do hope so. And now for the last one. Write these fractions as exponentials. Meaning we are basically backwards engineering what we did here on exercise number 2. Okay, this is also a skill you must possess when being a math student or later studying mathematics. You need to be able to turn fractions into exponentials yet again. So a squared over a to the 4th power. I'm going to use a fact here that we have introduced in the sets of numbers playlist. Everything's connected here. Sets of numbers, first playlist, and here we go. We are working on it again. So each fraction a over b can be written as a times 1 over b, leaving us with, okay, this is our numerator, so a squared times 1 over a to the 4th power. And this is good, right? I mean, now we can just make use of what we did here. We are going to backwards engineer our mnemonic device. We are going to turn our fraction bar into the negative sign, leaving us with a squared times a to the negative 4th power. Ah, this is good, right? I mean, now we have the same base, but different exponents basically, meaning we're going to collect our same base and we are going to add our exponents together. 2 minus 4 is going to give us negative 2 basically, a to the negative squared, and thus we are done. Now let us continue with this one. It's the same procedure. We are going to drag our numerator to the front at first to make things more clear. This is 3 squared times 1 over 2 to the 3rd power. Now we are going to turn our vinculum into a negative exponent, leaving us with 3 squared times 2 to the negative 3rd power. And then we are already done. That's an exponential. Works wonders, right? Now, 8 over 4 squared. This is quite a nice exercise because you can do a lot of manipulations with the exponents after actually turning this into exponentials. But I'm not going to go into too much detail. We're going to turn it into exponentials now and see what we get. So bring the 8 to the front. 8 times 1 over 4 squared. 1 over 4 squared, turning the vinculum into a negative sign, is 8 times 4 to the negative squared. And now we could stop at this point. I'm going to go one step further and say that 8 is nothing but 2 times 4, right? So this is 2 times 4 to the negative squared. 4 is nothing but 4 to the 1st power, meaning same base, different exponents, leaving us with 2 times 4 to the 1 minus 2. 1 minus 2 is going to give us negative 1. And now we could go one step further because 4 is nothing but 2 times 2. And overall we could cancel out the 2 with some 2 to the negative 1th power. I'm leaving this as an exercise to the viewer, right? To simplify this a bit further. And we're going to end up with 2 to the negative 1th power being equivalent to 1/2, which does make sense because 4 squared is nothing but 16, and then we can cancel out the fraction, we can reduce it to 8 over 16 is 1/2. And thus we are done. Just a little exercise here for the fraction boys out there if you want to simplify fractions a bit further. And now last one, this is supposed to be a 5 and not to the negative squared. Really doesn't matter, really doesn't affect the exercise too much. Now what is our numerator here? Well, everything we have up here. So let's rewrite this into 15 squared times a squared times 1 over 8 to the 2nd power. Turn the vinculum into our negative exponent, leaving us with 15 squared times a squared times 8 to the negative squared. And then we are basically done. I mean, the exercise really doesn't demand any more from you. But doing this, what you could do, what many mathematicians do, is they like to factor out our common exponents here. So what you could do, you could turn this 15 squared times a squared over 8 squared into 15 times a over 8 and the whole thing squared. This just follows from the fact that we have different bases but same exponents basically. Just as a little side note, so you could turn this into big parentheses to the negative 1th power, okay? I'm going to write it out, big parentheses, everything to the 2nd power, not negative 1th power. And then what was the common exponent? It's basically 15 times a times 8 to the negative 1th power. Just as a little side note. Those two are equivalent, and I just want to say 1 or 2 words about this. And this basically concludes our exercise. Did you get everything right? I do hope so. If you did enjoy this video, then please like, subscribe, and recommend channel if you like. Don't forget to take a look into other playlists that we are having here on this channel. There are a lot already here. And if you know about someone who needs maths help, like high school maths help, then recommend them this channel. If you do enjoy the content here, also recommend it to your teacher. Maybe he finds this content also pretty good and he would like to recommend it to other students of him. So yeah, other students of his. This is how you say it in English. And other than that, thank you guys for watching. Take a look at the main channel merchandise out. And until next time, I wish you guys a flamboyant day. Ciao!